So in the last video we saw the ordering of input arguments in a function, and we saw a fix to it. I mean, if there is a chance that you may miss a proper order, there is a way to fix that. We saw that in the last video. But here we have another thing to discuss. This x variable, x input argument, this is the variable that is defined inside a function, although the value it receives is copied from somewhere else, but it is defined inside the function. That is also the function variable, or the variable that is in the scope of the function, inside the function, in the body of the function, something like so. It may be handy, for example, let's say you compute something, you do some processing on your inputs, and whatever the result is, you save that result in another variable. And let's say now you need the value of this variable to do some further process. Let's say what you do is, let's say at the call time, let's say this is the function. Let's say this is the complete function, and let's say a is equal to 12 and b is equal to, let's say, 7, and let's say you call the function add a b. Now the value of a will be copied in x, the value of b will be copied in y, okay? And now you need the sum of a and b to be received here in a variable. You want a variable in which the result should be saved. For example, let's say the variable is d, let's say. And then you want to do some more processing on d, let's say d double star 5 mod 3, and maybe you need to apply an if condition on that. If that equals to 0, then do some stuff otherwise. So let's say you need this variable out. What will happen is this c variable is not accessible outside this function, and the reason is the c is defined inside the function. When the function body completes its execution, the c is lost. C is no more available. C is defined when the function call has been made. When you are executing this statement, C is defined, and a memory location was created in a C, sometimes called the function space in the memory, or process space, that is created in memory. But once all the body of the function executes, all the functions that were inside the variable, they're lost. How can you receive this value? How can you receive the value inside C outside this function? So that is question in this slide. How can we do that? Further, this particular function can access all the variables that are not defined in this function, but that are available outside this function and are defined already. For example, let's say I have a function f, and the function is let's say I have a function f, and so if this function is defined like so, f, let's say f is your function, and it is defined like def, and that's it. And here it prints, let's say, some variable, let's say a. Let's now this a variable is no longer in f, not even defined in f, but as long as this a variable is defined before calling f, for example, that's the cell where we are writing the code, and we say, okay, a is equal to 7, and then we just call this f. Because a was available before calling f, a is accessible here. So the functions, the variables that are available before the call, they are available inside the functions, but the variables that are defined inside the functions, they are not available outside. That's a problem. Further, if we define this a here, a is equal to 2, now this a is sometimes called the local variable, or the function variable, the variable that is local to the function. Now this a is defined inside the function, and all the accesses to a will access this value 2 rather than the 7. Consider the 7 has a separate location in memory, and this 2 has a separate location in memory. Both have names a, but this a will only be referred to when the function is executing. after the execution of the function completes, this is gone from the memory, and this will still be available. This 7 will still be available. So it is good to know. And by the way, if a was not defined here and you still called f, then either you will be getting an error, or this a might be a global variable or available in some package that you have already loaded or stuff like so. In that case, this a will be accessed if it's a global variable or accessible. So it is good to know the scope of the variables inside the function, because when you're calling them, what functions, if x is already defined, for example, if x is already defined like 34, and then this x is 34 as long as this x is not defined here. If x is defined here, this x actually is the local copy, and that will be accessed inside the function. Once the function is gone, again x will be 34. So it is good to know the local copies or the function space itself. But the problem here is how to access this variable, the value of this variable outside the function, because this is completely defined inside. How to access that? Well, there is a fix, and that fix is called the return statement. If you write the return statement, for example, you return this value, so x plus y. You might have saved these values. For example, c equals x plus y. That's okay. And then you say, okay, return c. What will happen is, wherever you have called this function, d equals add, let's say 2, 3. Now this value c, which in this particular case is 5, that value will be returned in d. And all the properties of this variables are returned in d. So just like this, c is copied in d, and this is available further, whatever you want to do with this d. Okay, so yeah, so return statement is there. So in the next video, we will actually code this in Jupyter Notebook and see the return statement running, and we will see the scope of the variables and all that in Jupyter Notebook. So hope to see you in the next video.